Okay. So we have 2 to the 3x equals 5. Okay, when we want to solve this problem, it's a lot like the natural log problem, but in this case, the e we knew was the natural log base. In this case, we don't have a definite base that we can use, but we know that any log base b of the same base is equal to 1. So any log based the same number letter as what it's taking of is equal to 1. So that's why ln e, or ln is the log base e of e is equal to 1. That's why ln e is equal to 1. Because it's got the same base as the number it's taking. So if we can get this, we can get rid of that 2. But to do that, I need to take the log base 2 of 2 to the 3x equals to log base 2 of 5. Because what I do to one side, I got to do to the other. It's just like algebra. Okay? So now I can pull out my power rule. It says, hey, since I'm doing a power inside here, it's my product rule. I can pull that out, and that's 3x times log base 2 of 2 is equal to log base 2 of 5. And now I know that, oh, log base b of b is 1. So therefore, this is just 1. And so now I have 3x times 1 is equal to log base 2 of 5. And what I want to change here is 1, get rid of that number 1 there. Just have 3x. And 2, I need to change this so I can plug it in my calculator. Because I can't plug in a base 2. So how do I plug it in my calculator? And it was that little trick I showed you of putting that like that with that log underneath. So it's log 5 over log 2. And so now I can just divide by 3. But if I divide this whole fraction by a whole number, I have to remember I'm really flipping and multiplying. So instead of doing that all complex, I'm going to multiply this by 1/3, and that's 3 over 1. And then I do the same thing to this side, 1/3. So now these 3's cancel nicely, and I get x is equal to log 5 all over 3 log 2. And that's solving for logs.